Hey guys, today we're going to be talking about the different properties of logs. The properties are going to help us with expanding and condensing, which eventually will lead us to solving. All right, so here we are talking about the identity properties of logs. This will help us when it comes to simplifying some just rules that you'll see and just understand how to work with them. The first example over on the left side, you'll see the first one is a log base b of 1 equals 0. So in other words, it doesn't matter what your base is. If it's of 1, then it will always equal 0. So for example, our first example, log base 200 of 1 will then automatically equal 0. And what you're doing, if you haven't kind of figured this out or put it together yet, you're asking yourself 200 to what power will equal 1? Which is this of part. So 200 to the 0 power is the only number that we could plug in that would give us a 1. Anything to a 0 power equals 1. So this is where it's coming from. On the next one, you have the natural log of 1. Now remember, this is the same as log base e of 1. Same idea. So it doesn't matter what our base was, it was an e. This is another example that our answer would equal 0. All right, so for the next set of examples, we have a log base b of b to the m power equals m. So what that's saying is this log base b over here on this side of b, if they essentially are kind of canceling each other out, because we've talked about that before, and you're left with our exponent power of m. So whatever that exponent value is, that's what it will equal. So for our example underneath, log base 2 of 2, those are the same thing. So those are going to essentially cancel each other out, leaving our exponent of 4. So our answer is 4. In our last identity, this is very similar to the one that we just talked about with the m for the exponent value. I know before we had the m here, everything else would be the same. If for some reason, again, the log base of b match, then whatever power, and if it's not written, everything has a power of 1 would be your answer. So the same idea is going to be here. So log base 5 of 5, this 5 has a power of 1, even though it's not written, it's just understood. That means our answer is 1. All right, so before I get started with the product property, I want to kind of talk to you a little bit about expanding and condensing. Like visually, what does it look like? As you can see on the left side, we have this is more of a condensed version. Everything is really small. It's compact is what I like to use. You don't have the word log written multiple times. This would be your condensed version. This is what it looks like when something is being condensed. Now, to the right of the equal sign, over on the right side, you'll notice that you have the word log written multiple times, and it's separated with a plus or a minus. To me, this is more expanded. This is a longer version. There's lots of words, and that's the difference. We want things to go from condensed to expanded, and we'll take things from expanded version to a condensed version. So understanding that idea will help us go, continue on through the rest of these properties a little bit better about what we're looking for. And lastly, please make sure that you understand that just because something is in condensed version and you expand it, they will be equivalent on both sides of the equal sign. There's nothing that should be different about them. If you were to plug in a value and put it in your calculator, the left side should equal the right side if you did it properly. Okay, so looking at this product property, let's talk about what the rule is. It is pretty much telling us inside the parentheses, if I have two values being multiplied together, or it could be more than two, then that means when I break it apart into the expanded form, that multiplication is going to turn into addition. Just like if you can remember your exponent rules, when we multiplied variables, we added our exponents. Logs are similar in that aspect. If we are multiplying variables, then when we break it apart, we're going to put it into addition. So let's look at our first example. We have our log base 3 of 6x. I like to look at and decide how many parts or pieces I'm going to have, so I know how many pluses I'm going to end up needing. So between the 6 and the x, that's 2 parts. That means I have a 6 and I have an x. If those are being multiplied, then that means I am going to be adding those together. Now, every time I have a part, I am going to write the log base 3 with each part when I go to expand it. So for example, what this looks like, I'm going to write log base 3, and then my first part was 6, so it'll be log base 3 of 6 plus, and then I'm going to repeat my log base 3 of x. Now, some people like to have the 6 in parentheses or the x. Either way is acceptable. So that's our first example, going from a condensed to expanded form. Now, let's go backwards. If I have 2 parts and I have multiple words, like I have the log written multiple times, like in our next example on the bottom right, so we have a log base 4 of x being added to a log base 4 of y, that means I need to put it together. When I go to the condensed version, I will only write this log base 4 one time. So I'm going to have log base 4 one time. If I'm taking the x and the y, that means that when I put them back together, it's going this addition will turn into a multiplication. So log base 4 of x, y. So log base 4 of x, y. All right, guys, so here we are with our second property with the quotient property. And what that means is if we're taking and dividing two things or dividing something in our condensed version, when we go to expand it, that we're going to take that division and turn it into subtraction. So there's a basic rule that if it's in the numerator, it will be positive. It's in the denominator, each part will be have a minus in front of it. So let's get started with our first example down below, our log base 3 of y divided by 4. So we have, let's count our parts. We have the y in the numerator, so I would count that as a 1 part. And then we have a 4 in the denominator, that would be my second part. So that means I'm going to write the word log base 3 2 times. And since we have a division in the middle, we talked about it up above, that will turn into a minus. So going to the right side, we have log base 3 of y minus a log base 3 of 4. All right, so let's take a look at our second example. Our second example below is already expanded, and we're going to go the other direction, and we're going to condense it. So you'll notice we have a log base 5 written twice. We have a minus in the middle, which means that's going to turn into division. So whatever came prior to that will be in the numerator, the 3, and the c will be in the denominator. So let's write it one time on the other side. So log base 5, writing it one time, of the 3 goes first, so we'll put it in the numerator. Then we have the minus, which means division, of c, and then close parentheses. So log base 5 of 3 divided by c. All right, so here we are with our last property that we're going to talk about today, and that's our power product property. We are going to, if we have an exponent, what it says is if you, in the condensed version, you see this little n, it's in the exponent spot, it is going to be moved when you go to the expanded out front of the word log. And whatever that exponent is touching is what it has to be moved in front of. So depending on how many parts, there could be multiple parts. In this case, in our example, we have 1. So let's look at our ln of y to the 5th power. Now when we go to expand it, I only have 1 part, which is fine. This 5 is my exponent. It's going to move to the front of the ln, and we're just going to write 5 ln of y, and that's it. And then our last example, we're going from the expanded form to the condensed version. So in this case, we have a 3 in the as our coefficient out front. Because of that, we need to go back, and we're going to put the 3 back where it started from in the exponent position and rewrite it. So we'll have log base 3 of x, and we're going to put that power of 3 attached to the x on the outside of that parentheses. And that would be our final example.